Okay, this is the Iceland volcano. As you can see in the lower image, which I'm now going to zoom on it, you can see the clay pan which was there and it looked beige color is now disappeared and covered by the by the lava. The lava is oxidizing very quick. Look, the color of it is changed to kind of brownish color. And what I can say also is that this is a glacial valley. Of course, you can see it's U-shaped. And this was, there was some drop stones, glacial drop stones, larger stones that were dropped from the surface of the ice, top of the ice, which was on top of these hills you can see here, and even above that. And when the ice melted, they gradually, as ice melted, came down. And you know that when the stones, they get hot quicker than the ice. They absorb the sun's rays quicker. And it made a hole and eventually fell and touched the ground. It was there since the last glacial age. And now it has gone. It's disappeared under the lava. You don't see, you can see the tourists standing there. And who knows in the future when there is erosion, millions of years from now, when there is enough erosion, who knows how many kilometers of the sediments will be on top of this. It may resurface again, like the way that we have found meteorites and drop stones in some rock formations in Sweden, in America, in Vietnam, in China, many other places. We find interesting bits in the lava, trapped in the lava. And a meteorite also has been found in such a setting. A drop stone, a time capsule from our time, is now trapped in the basaltic lava of the Iceland, the latest volcano there. As you can see, the eruption is starting, it seems. Yeah, the eruption is starting. This lava is very hot, is silica poor, so silica is like a polymer. In that case, it acts like that, makes lava sticky. In this case, not having enough silica. And at the same time, it has lots of water content. You can see the steam. The gas visible, you see there, mostly is water vapor. Volcanologists know what I'm talking about. Please don't criticize if you don't know about igneous geology. Anyway, there are many resources you can study online. I'm not being snobbish or anything. Just understand what's going on. I'm trying to all of us to understand what's going on here. And yeah, look at the lava is flowing now. It's a bit less runny than the last time. Oh, look, it's overspilled. Overspilled over the wall of the crater and the channel. It cannot take this. The channel, the lava tubes cannot take all of that. Look at that. I've seen a video actually that when the eruption began in, I think, February or March, it was 400 meters high, the eruption sometimes. So we can say this volcano can actually grow as far as 400 meters and yet being able to spew some lava into the air. It has now become stronger and bigger. So we will have a long time to observe this volcano. It may destroy its walls, it may do all kind of things, but I don't think that will stop. It will go for decades. The source of it is in the mantle, deep mantle. As we know, how the water ends up, by the way, in the lava. Okay, those who have knowledge of the modern igneous geology, they will know that when you have subduction, and we had in the two sides of the Atlantic subduction. There are evidence for it in the form of volcanoes and mountains. When you have subduction, accretion which is wet practically. It has a lot of fluids in it. Also minerals that have water in their chemical composition, like biotite maker. They've survived the subduction into lower mantle, almost touching the core of the Earth. Then there was surface. Resurface is funny just to imagine that when the slabs of the continental crust sink into the subduction zone and they come down and touching the core, the solid outer core, liquid core, outer core, they bounce back sometimes as hotspots. This hotspot you see there over the Iceland is practically one of the examples of that. They have, in the chemical composition of them, lots of water. The vapor you see here is what, tourist is passing here. Anyway, so we have another person passing. Oh yeah, that's nice, actually give a good contrast. Anyway, so the water exists, and not in the form of the liquid water as we know on the surface of the Earth. It's in the crystalline structure of the rocks and sediments that form the thick continental crust. When we say thick, it means up to 50-70 kilometer thickness. And because they're practically buoyant slightly, they will come back later. They will not melt completely. And there is no melting actually in the deep in the mantle. Melting in that depth is impossible. Because it's under pressure. When there is pressure, nothing melts in that sense. When the pressure is removed, like this one, extension of the mid-Atlantic ridge, the pressure is removed, the things start to boil up and you can see the eruption like this happening. It's practically a splitting of the ocean crust, which is now surfaced, is resurfaced. It's surfaced at the, at this, above the ocean. Good example of it is the Afar Triangle in the Djibouti and Ethiopia and Eritrea. We have other examples. This is another example of it. Of course, it's a hotter spot. But again, you see the crust being formed. A continent, practically in the form of Iceland, is growing by this volcanism. Is a core of a continent, future continent. If you want to know how in the past of the Earth, the crust of the Earth shaped in the Hadrian times, birth of the solar system we are talking about. Look at the Iceland. You can see that how volcanism creates land masses. Land masses gradually grow, and over millions of years, of course, this may be a new continent. Imagine that. Long after all of us are gone.